Yeah, welcome to Point to Point channel. So, as part of Java 8 series, today I will discuss about Lambda expression. Yeah, let's learn the concept with some example. Yeah, so here if you see, prior to Java 8, whenever we want to give an implementation to a interface, okay, which has either one single abstract method or more than a single abstract method, no, only there were two ways. Either you need to create a separate class in which you need to give a no implementation to all those abstract methods, right? So this is case one, and case two is, and you need to give a implementation with the help of anonymous inner class. So these were the only two possibilities prior to Java 8, right? So I just want to show you once again what we used to do earlier, I mean prior to Java 8, right? So here if you uh, see I have one interface with the name multi method, in which I have two methods, m1 and m2, right? So now, you know see, I want to give a implementation to that m1 and m2 methods. Okay, so how we used to do prior to Java 8, see, the multi method, okay, multi method is equal to new multi method. Yeah, see, um, like this we used to give a implementation. So for example, I'm just giving something like, um, second, yeah. So I'm just saying hi, okay, hi str, okay. So I just gave implementation. So here I am giving implementation as, x plus y. Okay, so yeah, we are good. So yeah, so we are good. Now, in order to invoke this m1 and m2, what we used to do earlier, see now multi method dot m1. Okay, so dot m1. So I'm just passing, okay, uh, Ravi. Okay, Ravi. Okay, and similarly multi method, okay, dot m2 dot m2. Okay, I'm just passing some 10 comma 20. Okay, so yeah, so the second method m2, just returns some numeric number. Okay, let me enclose that in some SOP. Okay, so here, okay, so we are good. Okay, let me run this. Yeah, see, we have got the output, right? Hi Ravi and 30. So so this is how we used to implement a interface using anonymous inner class concept prior to Java 8. Okay, so then Java 8 team has come up with some idea. So what they thought here is, okay, so when we have two methods or three methods or more methods, okay, this way is fine. But what about, if an interface has a single abstract method? Okay, so let me show you that particular concept also. So here, see, I have one interface, wish interface, in which I have a greeting method, right? So let me give you implementation to that wish interface. Okay, so here wish is equal to new. Yeah, see, first let me give the implementation using anonymous inner class. Okay, so here, the return type is void, right? So what I'm doing, okay, um, okay, I'm just saying hello, hello user. Okay, okay, so obviously to invoke this greet method, what we need to do, uh, yeah, we need to invoke this greeting method, right? So here I'm just passing some name, Rajendra, right? So let me run this. So nothing fancy. I mean, I just gave implementation to one more interface which has a single abstract method, right? So see, we have got the output, right? Hello, Rajendra. So now, what Java 8 team thought, when we have an interface with single abstract method, okay. So even why to write this much boilerplate code, okay. So what they thought, okay. Anyhow, we know, okay, which interface has always a single abstract method only, that we know, okay. So then, is there any way to avoid this boilerplate code? See this new wish, this curly brace, public void, greeting method, this is kind of a repetitive code, right? Why? Because we already know that wish interface has a single abstract method, So whatever the implementation you are going to give, obviously that is a implementation for one and only single abstract method, that is greeting method only, right? Then again, why to specify explicitly I am giving implementation they like this public void greeting? Okay, so they just thought like this. Okay, then they just came with an idea of lambda expression. Okay, so now I will show you how to give the same implementation using lambda expression in a more simplified way. Okay, so now if you see wish, okay, obj is equal to, okay, so what they thought is, out of this entire implementation, what is the main key logic and key portion, key piece of code? Obviously, so this piece string user, so that means the input which we are passing, okay, and after that, the main body. Which body? So this body. So this body actually consists of the actual implementation, and this is the input parameters which we are passing. So these are the main two key portions of this single abstract method implementation, right? So then they thought, okay, so let's eliminate the remaining part. Let's consider the only this part. So now I'm just considering this part. Okay. So here, if you see, see, I just considered the same part. Okay. So then, we need to connect these two pieces using lambda expression. So the lambda expression is something like this. Okay, so yeah, we just need to have a semicolon. See now how simple it is. The same piece I just extracted from here. Okay, I just connected these two pieces with the lambda expression. That's it. I didn't do anything fancy, right? So now also the same story. I mean, here if you see wish dot greeting, right? So now again, let me invoke the same thing. So obviously here obj. Okay, so let me pass a different name, Ajay. Okay, so now let me run here. So it will give the hi Ajay. I mean hello Ajay. See, you have got hello Ajay, right? So how it is working in the sense, so whenever you invoke the greeting method and you are passing Ajay, okay, so this Ajay, string is passing to this particular input, that is user. Okay, so now the user is having value Ajay. Okay, so then straight away this piece gets executed. So by that way you are getting a output of hello Ajay. Okay, so this is how they just thought in a Java 8 team. Just they come up with a this excellent idea of using lambda expression. you know so now even in the if you have a single line implementation, then you can eliminate this curly braces also. I'm just eliminating this curly braces. Okay, so even this piece. Okay, so here if you see now also you will get the same output. So basically, when you have a single line implementation, you no need to enclose within the curly braces. That's what I'm trying to say. See, hello Ajay. Okay, and even you can remove this data type also. Why? Because the compiler is smart enough to identify the data type automatically. You can eliminate the data type. Okay, so and even you can run this. Again, you will get the same output. See, hello Ajay. When you have a single input parameter, even you can eliminate this parenthesis also. Okay, so let me run once again. see you have got the same output, right? See now how simple, you know, the way you have implemented a interface which has a single abstract method. See now the wish has a single abstract method, right? That is greeting method. See in a very simplified way. So this is the actual implementation now, right? So in a similarly, let me give you the one more interface we have, calc. Okay, so which has a single abstract method, add method, which is expecting two input parameters, and it is having a return type of integer. Okay, so now straight away I will give you a implementation using the lambda expression. So since you have got a good understanding of lambda expression, okay, so now if you see cals, okay, cals is equal to, so here how many input parameters are there? Two input parameters. So parenthesis is an required. So now so I'm just giving x comma y. Okay, x comma y. See the lambda expression. Okay, so first I will show you. See these curly braces. Okay, so here we have a return type, right? Return type of integer, right? So what I'm doing, return x plus y. Okay, so I'm just giving something like this, and you need to use the semicolon here. Okay, so this is the actual implementation. So this is the actual implementation to that single abstract method, that is nothing but add method. Here you can see this is the add method. Yeah, right. Obviously now how to invoke this add method? If you invoke the add method, then only this piece gets executed, right? Then only it makes sense, in executing this piece. So obviously what I will do, so cals dot add. Okay, so I'm just passing 10 comma 20. Okay, let me pass 10 comma 30. Okay, you can pass anything. Okay, so so basically it returns, right? So I mean, let me include in SOP statement, then only you can see the output. Okay, yeah, so let me run. So you'll see the output of 40. Yeah, so 40 is there. See how simple it is, implementing a functional interface, which has a single abstract method. Okay, so now even this, as I said sometime before, when we have a single line implementation, no need to keep in a curly braces. Okay, let me remove this curly braces. See, I just removed. Okay, so then, okay, let me keep in this single line. Okay, when we have a single line, even return keyword is also not required. Okay, compiler is smart enough to understand. Okay, it has a return type. Okay, so let me run once again. It will give the same output. Of course, see this parentheses are required. Why? Because here in this case we have two input parameters. See now also we have got the same output, right? 40. So I hope now you have got a better understanding what is lambda expression, when we need to use this lambda expression, right? Okay. So let me show you four more examples. Of implementing a predefined functional interfaces like consumer, function, predicate, supplier, all those things. Okay, so as I explained in my previous videos, we have almost 43 predefined functional interfaces which are located at java.util.function package. Okay, so out of those 43, the main four pillars are, consumer, function, predicate, supplier. Okay, so I just want to show you how we need to give a implementation to those interfaces. You know, so let me show you. Yeah. So here, if you see, I have one class lambda consumer. Okay, I have an array list of six values, 1 2 3 4 5 6. Okay. So now I just created a object for this particular class. Now uh, I just want to write one more separate method. Let's say I can give any name. Okay, I'm just giving accept element, something like that. Okay, so inside that I'm just passing this particular list. See now I want to um, the second parameter I'm expecting a int consumer. Int consumer is a predefined you know functional interface. So basically, it is a consumer only. As I said, let me give you a recap. What is consumer? So consumer is a function interface which has a single abstract method, that is accept method. So basically, this accept method, expects a single input parameter, and the return type is void. It doesn't return anything. So this is a consumer. So int consumer in the sense the same thing, but the input parameter is a into integer. That's it. So now the second parameter I am expecting a int consumer. So obviously that is a interface. Now you need to give a implementation right to that interface as an argument, right? So now so as I said, int consumer as a single input parameter. So try to leverage the knowledge whatever you have gained so far. So now, okay, I'm just saying my input parameter, I'm giving just name as t. You can give any name, this lambda expression. Okay, so return type is void, right? So I'm just saying some sop. Okay, so I'm just saying the same t. I'm just printing the same t. Okay, so here let me create this particular method. See, the same method. Okay, let me convert to this int consumer. Okay, int consumer, uh, int consumer. Okay, so inside this, let me try to iterate the elements of this particular list. Okay, so list. Okay, see, in Java 8, iterable iterable interface has a default method for each method. So obviously everybody knows, list interface, collect interface, collect interface, iterable interface. So by that way, list interface has a access to that for each default method, right? So that's what I'm trying to do here. Okay, see for each. Okay, so let's see what is there in the for each. Okay, what for each expects. See, for each expects a consumer interface. So since it is an interface, obviously you need to pass argument in the form of implementation, right? You need to pass some implementation, right, as an argument, right? So how we will pass implementation in the sense. Okay, so obviously how you will pass implementation to consumer. So just now we discussed it, right? You can give any name. Okay, so let me give, okay, some name, any name. Okay, t lambda expression. Here you need to give a body. So in this body you can give anything as per your requirement. Okay, so in this requirement, okay, so what I'm going to do, is int consumer. Okay, so this int consumer, whatever the parameter I've just passed, right, that one. Okay, so I'm just invoking this accept method. Okay, accept method, I'm just passing this t. Okay, okay, so now what happens if okay, so see, I'm just invoking this accept elements. Okay, I'm just passing two parameters, list comma and some implementation to this int consumer. So this is the actual implementation. This highlighted piece is actual implementation to the int consumer, which is a function interface. Okay, now of course, so this highlighted implementation, from now onwards, this int consumer is pointing to this particular implementation, right? So now how we need to invoke this implementation in the sense, obviously, that the int consumer internally having a single abstract method, that is accept method. So you need to invoke that accept method, then only this highlighted piece gets executed. So now here if you see, I just started iterating this list with the help of this for each method. Now in this implementation, here if you see, int consumer dot accept method. So the value what I'm passing t. So this t is nothing but this t, right? This input. So in the for each, in the sense, first we will get one. Okay, we will get one. Okay, next iteration we will get two. Okay, something, the same element we are just passing to this accept method. Okay, so this, if you pass one here, okay, the same one okay, will reach to this t method, and by that way it will just executes this body. Okay, I hope you understand. Okay, so uh, so what I'm trying to say is, this is the implementation of the accept method only, which is a single abstract method of int consumer interface. Okay, now in order to invoke that accept method, see, I just invoked something like this accept method. I'm just passing a dynamic input parameter. So um, so something like this. Okay, so the value whatever you are passing, it gets injected here, and by that way this body gets executed. So let me run this, and you will see the output. Yeah, here you can see 1 2 3 4 5 6. I hope it is clear. Okay, so yeah, yeah, let me show you the next example. Okay, so this time lambda function, right? So here also let me write one more method. Okay, lambda. Okay, lambda. Okay, lambda function. So let me give one my method name as map elements. Okay, here also I'm passing the you know two parameters, list comma. Okay, so this time um, I would like to give you implementation to the function interface. So let me give you a recap. Function interface, function is a functional interface which has a single abstract method. No, the method name is apply. So basically it expects a single input parameter, and basically it returns a it returns a no it is a element, okay, which could be of the same data type or a different data type. Okay, basically it has some return type that you can you know think in that way. Okay, so uh, so obviously, as I said, we have an input and we have an output, right? So now, okay, so first give me the input. Okay, I'm just giving t. Okay, so this is the lambda expression. So as I said sometime before, if you have a single line implementation, no need to give a return keyword also. So what I'm giving, okay, t, okay, t into t, okay, so t into t, okay. So this is the implementation to that function interface. Now in this case, let me take a int function, okay. So now let me give the implementation here, okay. So yeah, I have a method, okay. Let me change this object to int function. Yeah, so far we are good, okay. So let me iterate this for each, okay. Okay, one second. Yeah, for each, okay. So this is a consumer, okay. For each expects a consumer, right? So here, we are just doubling this value t into t. So let me include in a SOP some SOP. Okay, what I'm going to do, okay. So int function, okay, dot apply, okay, int function dot, okay, apply of t, okay, the same t I will pass, okay. So okay, so one second, any apply of t, uh, showing some error. Okay, class or interface expected. um okay, second. Yeah, so nothing, I mean, here I just have one extra curly brace, okay. So yeah, so let me run this, okay. So here, let me just to give you just a recap. So I have a second parameter as int function. Okay. So I'm just giving a implementation, right? So this has a single abstract method, apply method, single input parameter, and this is output return type of t into t. Okay. So I just invoked with the help of this dot apply. Okay. See here, you can see the same output. Okay. I hope it is clear. Okay. So now if you see one more example, okay, so this time, okay, let me take you this. Yeah, see, I have one predicate also, okay. So let me give you a recap. So predicate is a functional interface which has a single abstract method. The method name is this one, test method, okay. So basically it expects a single input parameter and the return type is boolean, okay. So now, okay, I want to give you implementation here, lambda, okay, lambda predicate dot, okay, let me give you some name to my newly created method. Okay, I'm passing two parameters, okay. So list comma, okay. So this time I will take a predicate function, okay, sorry, predicate, which is a function interface. So this time let me take a int predicate, okay. So obviously I need to give implementation, right? So t, okay, t, okay. So what I'm doing, t percentage, okay, 2, okay, equal to 0, okay. So basically I want to print even numbers, right? So let me create that method, okay. See, this method is ready, okay. Now let me change to int predicate, okay, predicate, yeah, yeah, we are good, okay. So so let me iterate this list dot for each. Okay. So let me take some. Uh, okay. Since for each expects a consumer. So here, okay. Let me take a block. Okay. Let me take a block. No. So this block is. So what I will do. Okay. If okay int predicate dot okay test okay test test of t, okay, test of t, I'm just passing test of t, okay. If you invoke this test, obviously this t will be passed to here, this implementation, okay. So basically it will return either true or false, right? In case if it returns true, okay, so what I'm trying to do, okay, system.out.println, okay, I'm just printing that t, okay, just printing that t. uh, yeah. So here, okay, it's showing some um, okay, I'm closing this, okay. um, 1 second, so let me see. So this is closing here, okay, we are good, okay. So this is here, okay, this is here, okay, okay, yeah. So one more curly brace is missing, okay. Now we are good, okay. Let me run. So basically now it will print only the even numbers, okay. See, it has printed only 2, 4, and 6. Okay, even numbers. So basically, so now with the help using this lambda expressions concept, now I think you have observed one point here now, right? So now even we can pass straight away implementation in the form of method argument. See, now basically in predicate is a interface, okay. So obviously you need to pass some implementation class as an argument to this particular int predicate, right? So the same thing what we are doing here, okay. See, in a single line we are just passing implementation as an argument. So this is a feature of functional programming, okay. So let me show you the final example. So that is this one, supplier. So supplier is also a fourth pillar of that predefined function interface. So here, what I'm doing, lambda, okay, supplier dot, okay. So let me give some supply elements, okay, some method, okay. So in this method, okay, here I don't have any array list, okay. So this time, um, so let me give you a recap of what is supplier interface. Supplier is a functional interface which has a single abstract method, that is get method. Okay, basically it does not expect any input parameters, and it will always have a return type. Okay, so now since there is no input parameter, okay, so what I am doing, okay, so this is lambda, okay, I am doing math dot random, okay. So let me create this new method, okay. So here let me take double supplier, yeah, double supplier, okay. So here what I'm doing, so double supplier, sorry, okay, double supplier dot get as double, okay. Since I have taken a double supplier, we need to invoke get as double, okay. So that's it, okay. So let me run this. So basically this get as double, what it does, okay, it triggers this supplier method, supplier implementation. So basically supplier implementation is a, as I said sometime before, there is no input, always it returns a output. So here, so okay, so 1 second. So So something went wrong. Okay. Math dot random. Okay. So double supplier. Okay. Double supplier dot get as double. Okay. Let me run once again. Okay. So let me pause this. So yeah, nothing. I mean, I just need to include, in SOP, right? So we were not able to see the output. Okay, let me keep in some SOP. Okay, so here, okay, so let me rerun this. No, so basically we are just giving implementation to the supplier, which is a function interface, which has internally get method. Okay, see, you can have a no random number, which is a double value. Okay, so yeah, so let me cover you one more final concept. Okay, so this is a consumer, right? So here, okay, so this is our implementation, right? Okay, let me keep this implementation in some block. Okay, in some block. Okay, so I mean, I just shifted that SOP to some block. I just want to show you something. Okay, so what happens in case if you have some local variable? Okay, so this time what I'm doing, int k is equal to 10. Okay, so this is not a final variable. Okay, so this time what I'm going to do, t plus k. Okay, so t plus k. Okay, so let me run this. Okay, so obviously instead of printing 1 2 3 4 5 6 11 12 13, this is expected output, right? So I mean, we can happily access a local variables which are declared outside of this lambda expression. So that's what I'm trying to say. But don't try to change the value here. Okay, so change the value in the sense, okay, what I'm going to do, k is equal to 12, let's assume. Okay, so immediately it will show a compile time error saying that what it is saying. So variable inside this lambda expression should be final or effectively final. So final in the sense everybody knows, okay, final int x is equal to 10. Okay, so that is the final since you declared a final keyword. But effectively final in the sense, even though you don't declare a final keyword, internally compiler will assume that, okay, this particular variable k is a final variable. Okay, it will attach that final keyword from its end. Okay, so that is effectively final. So don't try to change the value. Okay, that's what I'm trying to say. Okay, and so you can similarly, what about instance variables? Okay, so here private, okay, int x is equal to, okay, 20. Okay, uh, so see, this is an instance variable, right? So here if you see instance variable. Okay, yeah, so now if you see x is equal to 12. Okay, um, 1 second. So what it is saying, okay, non-static. Okay, so yeah, so basically this is a static method, right? So let me give a static method. See, now the error is gone. Okay, so now what I'm trying to show here is, okay, see, the initial value of x is 20. Now I'm changing to 12. Okay, now I'm doing some sum operation. Now it will suppose show, okay, 13 14 15 16. See, something like this, right? So the overall what I'm trying to say is you can happily access instance variables and as well as the static variables within the lambda expression, and even you can change the value also there. So I mean, there is no compile time error, but in the case of local variables you can access but you cannot change that value. So that's what I'm trying to say. Okay, So you know so even even outside also, for example here, if you try to change this value something like this, okay. um, okay, see k plus plus, till now there is no compile time error, so k is a local variable, but if I start using that k, okay, if I start using that k, immediately it will show the again error, okay, again the same error, okay, final, or sorry, this is never used, okay, but here if you see this error, okay, again the same error, final or effective error, final, okay. So I mean to say, if you use this local variable which is declared outside of this lambda expression, okay, so if you use that variable inside this lambda expression body, then immediately if you try to change this value, immediately it will say final or effectively final error. Of course, if you don't try to change the value, then there is no issue, and it will not show any compile time error. Okay. So yeah, that's it for this video. I hope I have covered all the lambda expression concepts. Okay. So here, you can pause this video and you can see the important key points. Okay. So yeah, so I just gathered all the important key points, whatever I have discussed so far. Okay, these are some main key points. So can we use lambda expression for interface implementation which has more than single abstract method? Answer is no, right? Similarly, this written keyword is really required when we have a single line implementation. Yes, no, written keyword is not required when you have a single line implementation. Okay. So similarly, can we access local variables which are declared outside the lambda expression? Yes, we can access, but we should not change the value. So that's what I just said. Okay, can we access instance variables and static variables inside the lambda expression? Yes, happily we can access, and even we can change the value of those variables also. Okay. So can we declare a local variable inside the lambda expression? Yes, we can. We can declare and we can change the value also. Nothing will happen. Okay, so that point. So here if you see, okay, let me see. I can create one new variable saying that int y is equal to 14. Okay, even I can use that variable. Okay, y. Okay, even I can change that va value of the y also. See, till now there is no compile time error, and even this will run also. Okay, so okay, um, so yeah, you can see you got the output, right? So the same thing, okay. Yes, we can declare and we can change the value also if you declare inside the lambda expression. Okay. So the next question, yeah, can we pass a lambda expression as an argument to a method? Yes, we can pass. This is a feature of functional programming. Okay, when the lambda expression body gets executed, obviously if you invoke that single method passing some input parameter, then only that parameter gets injected into that the actual lambda expression body, and that piece gets executed, right? So yeah, so that's it for this video. I know, if you really like my video, please like and share and subscribe to my channel. Thank you.